Alright, so I'm also going to complete this insect problem that is on the worksheet. It says the local zoo keeps track of the number of dragonflies breeding in their insect exhibit each day. Alright, so day 1 there's 9 dragonflies, day 2 there's 18, day 3 there's 36, day 4 there's 72, day 5 there's 144. Alright, and we have parts A, B, and C. A is going to ask us to determine which function best models the data. Alright, so you should be able to look at this data and know pretty quickly what type of function it's going to be. But let's just look at the table anyway. So we have 9 to 18, which is plus 9, 18 to 36, which is plus 18, 36 to 72, which is plus 36, 72 to 144, which is plus 72. Alright, so it's clearly not going to be a linear function. Alright, so next we want to see if it's going to be a quadratic function. So we can look at the differences again. 9 to 18 is going to be another plus 9, 18 to 36 another plus 18. Right there it tells you that it's going to be an exponential function. Alright, so how do we go from 9 to 18? We multiply by 2. How do we go from 18 to 36? We multiply by 2. 36 to 72, multiply by 2. And 72 to 144, we multiply by 2. So our common ratio is going to equal 2. Alright, so in our standard form of the equation, we have y equals ab raised to the x. First we can answer A, determine which function best models the data. It's going to be exponential function. Alright, then we want to write an equation for the function that models that data. So I'm actually going to go up here because there's more space. So let me rewrite this. Y equals ab raised to the x. Then with our common ratio, which is 2 to the x. Alright, and then we take a point off the chart. So let's just go with 1, 9. Alright, so 9 equals a times 2 to the 1. Alright, 2 to the 1 is just 2. So 2a equals 9. So a is going to end up equaling, you could either put 9 over 2 or you could have 4.5. Alright, 4.5 or 9 over 2. But now I know my equation for the function that models the data is going to be y equals 4.5. You don't need the parentheses there. That's fine though. It doesn't make a difference. Times 2 raised to the x. 4.5 times 2 raised to the x. Use your equation to determine the number of dragonflies that will be breeding after 9 days. Alright, well our days is our x coordinate. That's our input. So we're going to plug 9 in for x. Alright, so we have y equals 4.5 times 2 raised to the 9th power. Alright, 2 raised to the 9th power, you can either multiply that out or you can just plug 2 raised to the 9th power into the calculator and you end up getting 512. So we have y equals 4.5 times 512, and at this rate, if you were to plug that in and multiply, you end up getting after 9 days 2,304 dragonflies. Alright, 2,304 dragonflies.